So that's the first principle, is the Aufbau. There's three of them we're going to go over. First one is Aufbau. What's the second one? That's the Pauli Exclusion Principle. What does Pauli Exclusion Principle mean? Well, that means, you know those quantum numbers we were talking about for every electron? Okay, every electron has to have its own exclusive set of quantum numbers. Do you guys know what exclusive means? Only. Only. That's right. So this is the Pauli Exclusion Principle. So this is only. An electron is the only one that can have its own unique set of quantum numbers. No two electrons can have the same quantum numbers. Every electron has its own unique set of quantum numbers. Okay, so let's look at let's go back and look at our 1s. So let's draw our 1s orbital here. And how many electrons can I put in there? 2. All right, let's put them 2 in here. Now, give me the quantum numbers that go with the 1s. So what would it be? 1, 0, 0. Okay, 1, 0, 0. And we'll say positive 1/2, which is 1 electron. Notice we use the arrows to represent the spin. That's 1 electron. So if I were to put another electron in there, 1, 0, 0, uh-oh, negative. It has to be a negative 1/2. Why? Yeah, they have to have their own unique quantum numbers. That's right. Each electron has to have its own set of quantum numbers. So what that is saying, Pauli Exclusion Principle is saying, is that what it means is that I have to have 2 electrons of opposite spin. They can't have the same spin, can they? So every time we put 2 electrons in an orbital, they must be opposite spin. If they were the same spin, won't they have the same quantum numbers? Yeah, and that's not going to work, is it? Okay, so they have to be opposite spin. Not only that, but what if I tried to put a third electron in here? Is that going to work for me? Well, aren't these going to be the same quantum numbers again? Yes, I can't have that. Okay, so Pauli Exclusion Principle says each electron has its own set of quantum numbers. Therefore, I can only put 2 electrons in an orbital, and they must be opposite spin. 2 electrons in an orbital, and they must be opposite spin. All right, well, let's start practicing filling our orbital diagrams of these electrons. So let's do helium. Let's start with helium. So first we have to decide, how many electrons are we talking about in helium? How do you know? You said 2. How do you know there's 2 electrons? Periodic table? Well, I'm looking at the periodic table and I see 2 atomic number, but I don't see anything about electrons.
No, but atomic number.
Okay, good. You look at the atomic number and I see 2. That's the atomic number. That means 2 protons. But these are neutral. So if I have 2 protons, guess how many electrons I'm going to have? 2. If I have 3 protons, how many electrons? 3. So let's do helium. Helium has 2 protons, therefore I have 2 electrons. So let's remember those first 2 rules. Which orbital you're going to start with? 1s. And how many electrons are we going to be able to put in there? 2. And they better be opposite opposite spin. That's right, unique quantum numbers. So that's it right there. That is the orbital diagram for helium. We start with the 1s, you put 2 electrons of opposite spin. That's helium. This is called an orbital diagram. Okay? So I've got my circle here and I've got my opposite spin. So let's put that up there. So that's an orbital diagram. Well, what if I don't want to draw a picture? This is an orbital diagram, it's a picture. What if I want to write it out, like type it out? What would it be? Well, it's going to be 1s2. Okay, now how do we do that? Well, this 1 is the shell. Shell 1. Then we say subshell. Well, that was the S subshell. Then this number is the total number of electrons in the whole subshell. Okay? That's the total number of electrons in the whole subshell. So there were 2, so that's why it's 1s2. So this is called the electron. When we're talking about writing it this format, this is the called the electron configuration. Okay, that's the electron configuration. All right, well, let's do it again. Let's do lithium. Okay, how many electrons am I talking about with lithium? 3. Okay, so which orbital do we start with? 1s. All right, so how am I going to put the electrons in there? Okay, so I'm going to put an electron here, then what?
Another electron.
Another electron, but it better be opposite spin, right? Okay, we got to get to 3. That's 2. Now that that's completely full, we go to the next one. Just one. So that is the electron. That's the orbital diagram for lithium. Now, what would be the electron configuration? 1s2, 2s1. Do beryllium. How many electrons are in beryllium? 4, right? Okay, can you feel that? Where would it be? Okay, so I'm going to put 1 here, and then what?
Opposite spin.
Opposite spin. Then what? Do I go to the next one?
Yeah.
Okay, so up and then opposite spin. Now, normally we start with the up arrow, but you don't have to. It's only by convention that we do. You could start with the down arrow if you wanted to. It's totally fine. But we just do it orderly and you just start with the up arrow. Okay, so what would be the electron configuration?
1s2.
Perfect. All right, let's go. Let's see. We've done hydrogen, that's hydrogen. We've done helium. Now, the way mastering chemistry does it is it doesn't use circles or boxes. It uses little lines. So I wanted to show you that. And we did lithium. Okay, now this is boron. So you know how to fill boron, right? Boron has, what, 5? So it would be 2 here. Opposite spin, 2 here, opposite spin. This is full, and then go 1 more. Now, by convention, we usually put it in the first spot, but you don't have to. You could have stuck it over here. It's okay, or in the middle is fine, as long as you had one of them in here. Now, let's see, you're in mastering chemistry, and remember the order of energy is very important. So let's say you started with the 2p and you put 1 here. Then you did 2 here. Then you did 2 here.
Well, you started wrong.
Oh, there you go.
The lowest level first.
Perfect. Even though your answer looks good, mastering chemistry will say wrong. And it'll say wrong because
You have to fill that lowest level.
that's right. You have to fill the lowest level. So best clear it off and go again. So it will watch the way you're clicking to make sure you're getting the order of energy. Okay, so you got to remember that order of energy. Okay, here's more, right? You can do carbon. Here's carbon with 6. Now, this is where we get into the third rule, and that's called Hund's rule. That's our third rule. So we talked about 3 rules. Hund's rule. What is Hund's rule? Well, Hund's rule says that we occupy degenerate orbitals singly first. Oh, what was degenerate again? Same energy, right? Oh, good, good. So we occupy degenerate orbitals, same energy. Well, which ones are degenerate? So it would be all of these 3, right? Because all the boxes are touching each other? All right, so it's these that we're talking about, not those, these. So we occupy them singly first. So everybody gets their own orbital first. We don't want to share too much conflict, issues, perhaps. So we're going to do them singly first. So if I have to put 2 electrons, they go singly, then singly. If I have to put another electron in, where does it go? This one, singly, right? We don't double them up yet, right? It's like the bus rule. You know how you get in on the bus and everybody sits in a row singly first before we all start doubling up? Yeah, it's like that. You singly first before you start doubling up. Okay, so that's an example of carbon. Now, do you see how we did this one? All right, so here I have nitrogen, which has seven electrons. So how am I going to fill 7? 2 here, then go to the next energy level, 2 there, and then, okay, what did we say? Degenerate, you have to do singly first. So singly, singly, singly. That gives me 7. That gives me a total of 7. Now let's go to the next one, oxygen. Now oxygen's got 8, so this is where we go 2, 2, 1, 1, 1, and then back around to start doubling. Okay. And then, do you see about fluorine?
Question?
Yes.
You don't have to double the very first one. You can double each one of them.
Exactly. Maybe you like the west bedroom, not the east one, so fine, take the west one. It's okay. All right, so let's go here. Fluorine. Fluorine has 9, so 2, 2, singly, 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 back to double, and then double until I get to 9. Now let's look at the orbital electron configuration. If you were to say the electron configuration for this one, it would be 1s2, 2s2, 2p, 5. That's all total. That was the total number of electrons in the whole subshell. We don't say 2p2, 2p2, 2p1. We don't do that. It's 2p, and all together it's 5. Does everybody see that? It's 2p5. Okay, and then neon, that would be 2p6. Does that make sense? Okay, good. All right. See if you can take just a minute now and give me the orbital configuration, or orbital diagram and electron configuration for, and let's do sodium. Okay, so let's do sodium. How would you do sodium? Okay, how many electrons are we talking about for sodium? 11. Okay, got to fill 11. And you know where to start, right?
1s.
1s. Okay, you got to remember that order of energy. Isn't this the order of energy? 1s, 2s, 2p, 3s. Yeah, going with your.
3d, and then 4s, 4p, 4d, 4s.
Not quite. Yeah, we'll talk about that in a minute. Yeah, it gets a little bit more.
Yeah, the d starts from 4s.
Yeah. Well, the order of energy is slightly different. But we'll talk about that. Does it look like that?
Yes. Yeah.
Awesome. So what's the electron configuration? 1s, 2.
1.
Oh, perfect! 1s2, 2s2, 2p6, 3s1. Yay! Awesome. You guys can do it. And that's how we fill those orbitals. Okay. So we talked about Aufbau. What was Aufbau principle again? Lowest energy and building up energy levels, right? You start with the lowest, and you have to fill it completely before you go to the next one. What was Pauli? Exclusion. So what does that mean? 2 electrons in an orbital, and they have to be opposite spin. Perfect. And what was Hund's rule? Degenerate. What do you do with degenerate orbitals? Singly first. Exactly. Perfect. Those are the 3 rules that we just used. Okay, so let's take a look at these 3 diagrams. And what I want you to do is I want you to look at these and decide which one of these is a violation. We'll just stick them all on the same screen here. Is there something wrong with these? Okay, that's what I want you to decide, is what is wrong with these. And if it is something wrong, which rule did we mess up on? Okay, so talk it over with your neighbor and decide, hey, what's wrong with these? What's wrong with them? Well, look at that carefully. All of the electrons. Yeah, you know that's wrong, right? So that's what's wrong. It's okay to be singly first. That's Hund's rule. That's fine. That's nothing wrong with that one. But those 2 are wrong. Yeah. Oh, yeah. There you go. Nailing this stuff. Okay.
I just practice it off, like off and down. It's a singular, it's Hund's. It should be in the
Okay, what do we think? They're all wrong. Did you guys talk about which one, why it's wrong? Did we talk about why it's wrong? You have to tell me the name of the principle if it's something's wrong with it. You have to say what the name of that principle is. Okay, if it's wrong, you have to tell what principle did it mess up with, what was wrong, which one of those 3 principles caused the error. Okay, which one is the rule that's wrong? What's the matter with them? Oh, sorry. How we doing? Good? Okay. You look like you had a question.
Yeah.
I was like, I want to see if he has a question.
For the first one, I know it's Pauli, but it's also Aufbau because lowest energy gets first, and this one is lower than this one.
No, these are degenerate. They all have the same energy. So there is no lower energy there. Yeah? Yeah.
Yeah, I was thinking about that.
Yeah, so this is, remember that's our definition of degenerate means these are all the same energy, so there is no difference here. They're all the same.
Thank you.
Yeah, okay. Yeah. You like this chapter? Good. I thought you liked calculations.
I do too. I'm a physics person.
Yes, I was thinking, man, you ought to be really good at this math. You have to take 1412.
Yeah, I'm gonna take the next. I already put your class in it.
Oh, yay, because I'd love to see you in there again. It'd be awesome. It's really a lot more math, so you might like that. Do you? Oh, you're minoring in math?
Yeah, all of them, biology, chemistry, physics. It's biomedical engineering. So I had to do all of them.
That's...
My brother took your class last semester.
Oh, we did?
And his name is Papis too.
I thought that. I was like, I had a Pappas. I thought, well, that's weird that they have the same. I said, oh, I didn't know that was your brother. Oh, no way. You have to tell him I said hello. Oh, well, he was a good student too, and you're an awesome student too. Runs in the family.
It's in the genes.
Yeah, this is me in the genes. Gosh, you guys are awesome. So are we getting it okay? What are you guys thinking? Making sense?
Yeah.
All right. Okay. All right, so what did we decide?
First one is the spin.
Oh, so the first one, what was the problem? Pauli. Why is it Pauli? Yeah, you can't have the same spin. Didn't we say that? So this is Pauli Exclusion Principle. Is there a problem with this one here? No problem. It's totally fine. Hund's rule said you occupy degenerate orbitals singly first, and that is singly first. We don't have to occupy that bedroom. Maybe you like the west, maybe you like the east. It's okay, as long as you're singly first in one of those. All right, does everybody see that? So what's wrong with this one is Pauli. Okay, what about this one? What's wrong here? Aufbau, order of energy. Well, what happened? You skipped one. Okay, we can't skip one. We have to go in order of energy, right? Okay, and then, is there anything wrong with this one? Hund's rule. Why do you say Hund's rule? Occupy degenerate orbitals singly first. You can't have it doubled up there, right? We go single, 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 don't we? Okay, whoo, does that make sense? All right, so you know what those three rules are. You can use them to put electrons in our quantum model, and you're able to tell me what's wrong with these and specify the rule that goes with that, right? Okay, whoo, all right. So practice this, and we'll talk more about orbital diagrams, and we'll do even more of those with more atoms, and we'll do that on Monday. All right, good job.
And we'll know more information about like when we can do that survey.
Yes.
On Monday.
Yes. Yes. Okay, very good. Woo! Good job, everyone. All that thinking. That's awesome.
I did it twice for my super credit. Am I going to do it third time?